What's up, math scholars? It's day 2 of translating these graphs. So we're going to be seeing a lot of the same concept with one new concept added in, and that is reflecting. So go ahead and jot down these 3 concepts, and we will be talking about what putting a negative out front would do to a graph. I forgot to ask, who's excited? It's Tuesday. And Tuesday. Okay, so first things first, let's talk about sine graphs. Normal sine graphs start at 0, go up a mountain, come back to 0, go in the valley, and come back to 0. Correct? That's what a normal sine graph would look like. What do you think would happen if we plop a negative out front?
Opposite.
Yeah. Down in the valley first, and then up the mountain. So just draw yourself a sketch in your notebook so you know that a negative sine graph would look like this. Down in the valley first, back to 0. Up the mountain second, back to 0. So that would be one period of a negative sine graph. We're going to do the same thing and draw ourselves one period of a negative cosine graph. So let's recap what a normal cosine graph would look like. It would start up at the amplitude, end up at the amplitude, and in the middle it would drop down into the valley. So it's almost like a cereal bowl. I kind of use the word cereal bowl sometimes, right? That's what a normal cosine graph would look like. What do you think an upside down cosine graph would look like? Oh, that was a normal one. You wanted the normal one drawn? Oh, no. I'm going to draw an upside down one. I was recapping what a normal one looked like for them. Now I'm going to do my upside down one. My upside down one would start at the negative amplitude, and then it would kind of rise up, hit its peak at the amplitude, and then drop back down. So it almost looks like one big mountain. One big mountain. It's a negative cosine graph. And a negative tangent graph. You would still have your asymptotes. You would still have your halfway points. You'd still be going through 0, 0. But instead of kind of being a positive snake, snaking upwards towards the sky, it would be a negative snake, snaking downwards towards the ground. Negative tangent graphs. I'll click pause and let you guys catch up. All right, so here's our first example. There's a lot going on, so just take it piece by piece. Don't get overwhelmed. Do the best you can with your drawings. If they're not perfect, that's okay. Mine are never perfect. I will give a ticket out if somebody can start me off and tell me what A and B are. Lexi. Right, and I'm just going to go with the positive 2 because amplitude, you can do the absolute value there. But yeah, she's right. A is negative 2, but that makes the amplitude A2. And then B, what did you say? 2/3? Perfect. And we're going to use Lexi's B value to help us with our period formula. This is a little complicated. Our period formula is 2 pi over B. Yikes. We're dividing by a fraction? Good thing we remember how to do that. They don't remember how to do that. That's why they multiply by 3 over 2. Good, they do remember. 6 pi over 2. So 3 pi is our period. Good thing we did all those tangents last chapter, huh? Okay. Let's go ahead now and label ourselves 4 hash marks out. Before I go much further, I probably need to look ahead a bit and think about, is this going to shift right or left, up or down? What do you think? Right. It'll shift right, 3 pi over 4, and it'll shift up and down, none. So maybe, since I am going to go right, I probably want to be a little more conservative with how big I make my hash marks. We are going to be shifting right eventually. So many times I run myself right off the board because I draw my picture too big. All right, so it is a sine graph, but it's an upside down sine graph. How do I know it's an upside down sine graph? Right, so instead of starting at 0 and going up the mountain, we're going to start at 0 and go down the valley first. Now this is just my preliminary graph I'm doing with real light pencil, because I will have to perform that shift that we just talked about a second ago, right shift in a second. They already did the upside down flip, so that's good. Alright, so I have that really light pencil sketch. Oh gosh, I can't believe I forgot to do this and nobody said anything. Yeah, I forgot. You should have said something. You could have saved the day and got a ticket. When I found out my period was 3 pi, I really should have labeled that 3 pi. This 3 pi over 2. This one 3 pi over 4. And this one 9 pi over 4. But that'll help us out to figure out just how far we're shifting. We are shifting right 3 pi over 4. Forgot to write the 4 there. So we're shifting right 1 hash mark. Does that make sense? Because this hash mark is 3 pi over 4. So all my black dots get shifted into green dots. 1 hash mark further to the right. So that green line would be 1 period of the graph. You probably would start curving there if you want to curve it. Cool. And that's it for that one. So I'll pause and let you catch up. All right, it's a sunny Tuesday. We're having concentration problems, but we already do 2 more problems. This is just a simple tangent problem. There's no shift. There's no reflect. We wanted to just review tangents, so I think people struggle with them a little more. Can you raise your hand for a ticket and tell me what A and B are? Brittany.
A is 2 and B is 5.
Okay. So now we're going to go ahead. We have a different period formula for tangents. It's pi over b. Pi over pi is 1. So that measurement of 1 will go from this asymptote that I'm drawing in to this asymptote that I'm drawing in. Sorry, my board is not quite lined up right there. There we go. So basically the distance from one asymptote to the other asymptote is 1, making this a half and this a fourth. That 0, of course, and a fourth, negative a fourth, and negative 1/2. Where'd my questions go? My questions must be hiding. I normally have questions about period and stuff. So there's my period. It's 1. My asymptotes are at negative 1/2 and positive 1/2. And then I normally have a question about a halfway point. A halfway point is definitely going to be at 1/4 and negative 1/4, but then it's comma A, so comma 2. So 1/4 2, and negative 1/4 negative 2. So that wasn't bad. I wanted to refresh tangents before our next one, which is a tangent that is flipped upside down and shifted. Ooh, it'll be a challenge. Alright, we're going to end the day with this one. Go ahead and jot it down. I'm just going to talk you through what my eyeballs are seeing.
Did you finish the last problem?
Oh, yeah. Alright, I am looking for... Actually, I'm going to discuss what I'm seeing from. Be real quiet. It's our last one. I am seeing that negative out front. So I know before I even start, this tangent graph we flipped upside down. So remind me about that, because last period I forgot to flip myself upside down, and then the scholars were like, what'd you do there? That 3 is our A value. That'll kind of affect our halfway points. And that 5 is our up-down shift. So before I even start, I know there will be a 5 up shift. No horizontal shift. Okay? What do you guys think the period is? If A is 3, what's the B value? Just a 1. So the period will be pi over 1, which is this pi. So keeping in mind I'm going to be shifting up 5, I want to kind of give myself a pretty big y-axis so I have room to go upwards. So before I even start, I know I'm going to be going up 5 from where my original tan graph is. So I'm going to give myself a lot of labels up there. Okay, so my period will go from here to here. And that measurement from dotted line to dotted line is pi. Sometimes I draw it down here to see that. So from dotted line to dotted line, it measures out pi. So how far would it be from the origin to this dotted line? Pi divided by 2. Divide something by 2, you can multiply it by 1/2. This is a reflection image, so over here it'd be negative pi over 2. I'll just erase this a and b to give myself some space. I'll actually end up erasing this to give myself some space. So that makes my halfway point pi over 4 and negative pi over 4. So we can fill these in over here. Asymptotes pi over 2 and negative pi over 2. Halfway points pi over 4. And I'm going to kind of wait on the y value on that. Let me explain. Right now, the halfway point would be at pi over 4, comma a. So it'd be pi over 4, comma 3. I'll just kind of put a 3 here to remind myself about that. Maybe just real small in parentheses. And negative pi over 4, negative 3. And the reason I put it there, just real light, in light pencil, is I still have an up 5 shift to perform, don't I? So if this, at the origin, is shifted up 5, where would it now live? At 5. But this guy that used to be at 3, if he gets shifted up 5, where would he live?
8.
Good, so my halfway point is pi over 4, 8. I did it again, didn't I? This is going to be an upside down tangent graph. As soon as I wrote 8, I was like, crap it. Okay. I am having concentration issues too. Thank you, Lexi. You saved the day. Lexi's the best. All right. So, anyways, since it's an upside down tangent graph, we actually want our halfway point here at negative 3 and up here at positive 3. Here we go. And now we can do our up 5 shift. Alright, so this one still is going to live at 5. That's good. But this 3 will be up at 8. So it's negative pi over 4 that will be up at 8. That's an 8 right there. It's off the board a bit. And that negative 3, if it shifts up 5, it'll be up at 2. So it's pi over 4, 2. And then here, this black line I'm putting in is my final answer. It's up 5 and flipped upside down. I don't know why I've been having trouble remembering to go upside down with this. Oh, the first one, the dotted line one, would have been here. Yeah. This is a terrible drawing. Try to actually go through your coordinate when you do your drawing, unlike what I just did. But yeah, thanks for watching the video. Sorry we messed up this tangent one, even though I knew I was trying not to mess it up. So yeah, the homework you already have, it's 10.2 day 2. Have a fun Tuesday.